Right. In this video, I'm going to be recording solutions to the extra practice, those extra limits involving infinity problems. All right, so let's get it started. There's a lot of problems on this, so I'm just going to go pretty quick through them. But I'll be sure to put the number that I'm working at the top of the screen if you're scrolling through the video. All right, so we're going to start off with some textbook problems. Number 33, x approaches 2 from the positive side of x minus 3 over x minus 2. You go to plug in 2 and you get -1 divided by 0. That's a huge problem, right? You know that's a vertical asymptote. So what you're going to do is you're going to say, okay, I know I've got a vertical asymptote here. I'm going to choose a number a little bit bigger than 2 because I'm approaching from the positive side. And I'm going to say, okay, if I plug in 2.1, I'll have negative divided by positive is a negative number, and I'm approaching a vertical asymptote. That limit is negative infinity. All right, this one's going to be very similar. It's going to be, okay, I'll go to plug in 1, I get 3 divided by 0. I know that means I'm at a vertical asymptote, so that's 1. I'm going to plug in a number a little bit bigger than 1, like 1.01 or something. Now I'll get positive divided by negative. Okay, so that means I'm going down here, and my limit is going to be negative infinity again. All right, this one, same thing. We got to plug in 3, 9 divided by 0. All right, so got a vertical asymptote, plug in a number a little bit bigger than 3, like 3.1. Okay, 3.1 squared is a positive number. 3.1 squared is bigger than 9 also, all right? So, hold on, what is going on here? And so, yeah, over here it's positive divided by positive, and so it's going to be positive, and then we're going to approach our vertical asymptote there, and, well, I'm going to conclude my limit is positive infinity. All right. All right, now we've got one of the nice ones, right? We go and, okay, we're not approaching infinity, so we're going to try to just plug in, and I'm going to get 16 divided by 32. That's a half, okay? Let's move on. 37 is, okay, I'm just going to copy the problem. You don't need to watch me doing that. All right, so I factored the thing. I'm going to cancel these terms, and I'm going to plug in again and see what happens. I'm going to get -3 minus 1 is -4. Divided by -3 minus 2 more is -5. So I got -4 divided by -5, that's 4/5. Number 38, this one I'm going to need to factor as well. I'll copy the problem while I'll factor. All right, so I factored it, and there you can see, and wasn't the best factoring ever, but, you know, we got it done. We're going to cancel. We're going to plug in a half again. We're going to get -1.5 minus another one is -2.5. Divide by -1 minus 3 more is -4. And I'm just going to stop there, right? That's a good enough number for us in this class. All right. Copy the problem. All right, so you're going to factor it. You're going to cancel the factors that need to be canceled. And then you're going to plug back in again. You're going to get 1 divided by 2. And that'll be a half. All right, for this one looks like a direct plug. We're going to just say 3 minus 2 is 1. Divided by 3 squared is 9. And that's a 9. Right, this one, limit as x approaches 0 from the negative side of 1 plus 1 over x. Okay, what's going to happen to this thing? This is going to go towards infinity, right? But as we're approaching 0 from the negative side, we're plugging in like a negative number here. So it's going to negative infinity. If we take a number that's getting really large and really negative and we add 1 to it, it's still going to be getting really large and really negative. So that limit is going to be negative infinity. 42, limit as x approaches 0 from the positive side. Nope, that's that negative side. And that's, what is that? X squared minus 1 over x. Okay, that's going to 0. Subtracting something that's going to negative infinity is going to be positive infinity. And this is going to negative infinity. That is going to negative infinity because we're approaching 0 from the negative side there. Okay. And so I've got 0 minus something that's going to negative infinity, which is going to positive infinity. All right. 43. Okay, 2 over sine x as x approaches 0 from the positive side. And that's going to be, all right, think about what happens to the y coordinate as the angle approaches 0 from the positive side. Well, as we approach 0 from the positive side, the angle is going towards 0 but positive. So I'm going towards 2 divided by 0 along a positive number. You take something near 0, like pi over 6, and sine is positive. And so that's going to be a positive infinity situation. Because 2 is going to remain positive. This is going to 0. Okay, we got a vertical asymptote and it goes positive infinity. Pardon me. There was people in the back of my room. Saying, what are they doing? All right, and okay, number 44. Let's say negative 2 over cosine x. Limit as x approaches pi over 2 from. Oh man, I can't even see. It's very blurry. Okay, I think that's a positive. Yeah. So again, I'm going to be thinking, see that? I'm going to be thinking about the unit circle. I'm approaching pi over 2 from the positive side, which means I'm going up that way. Cosine is going towards 0, but it's negative on the way. So this is going to 0 and it's negative. I've got negative divided by negative is positive. I'm going towards negative 2 divided by 0, so that's going to be positive infinity. Okay, I'm going to zoom back out. 2 more of these. 45 is limit as x approaches pi of square root x divided by cosecant x. I meant to not include these, but I'll just show you what you do. You say, wait, this is 1 over sine, so I could kick this up to the top and call it sine x multiplied by square root x. And well, as x approaches pi, sine of x approaches 0. This is approaching the square root of pi, and the square root of pi times 0 is 0. Okay, we'll see it's very much the same on number 46, because the limit as x approaches 0 of x plus 2 over cotangent x is going to be, well, I could call that tangent x, divided by x plus 2, and I could take the limit of it as x went to 0. Okay, and then that's going to be tangent of 0 times 0 plus 2 is 0 again, because tangent of 0 is 0. All right, so I'm going to move on to section B. All right, so here we've got some limit as x goes to infinity type problems, and so we're looking, is it bigger on top, bigger on bottom, or essentially the same? This is essentially the same, because the biggest thing I see on top and bottom is x squared, and the coefficients of each of these is 1, so this limit is 1 divided by 1. Okay. This one is bigger on bottom, so I'm going to say that limit is equal to 0. Higher power, it's going to grow faster. Bigger on bottom goes to 0. All right, 3 to the x divided by x to the 3. This is bigger on top. Okay, and 3 to the x, if x is going to be a large positive number, that will be positive. This will also be positive. This is going to positive infinity. And let's see, music is playing in the background. And then this one, limit as x approaches infinity. Okay, we kind of disregard these because we're looking for the biggest power, and that's 3/2. Okay, because it's the ratio of the leading coefficients. This one is equal to 1, and I'll tell you, this is beyond where we're at this. But if you're interested in why, keep watching. If not, just, skip ahead 10, 15 seconds. Okay, I'm going to use log properties, and I'm going to say log of 3x equals log of 3 plus the log of x, and log of 2x is equal to log of 2 plus log of x. So if I look at this fraction, these are numbers, right? And as x goes to infinity, we're getting just closer and closer to, these are the only things that are growing, and they're essentially the same. We're going to, divide the ratio of their coefficients. Okay, that's why that one's 1. All right, so this one I just, it said divided by g of x squared, but then it told you what g of x was, so I just plugged it in like that. What are the horizontal asymptotes of f? Well, okay, this is the situation where it's going to be quadratic on top and quadratic on bottom. So if I was to go and distribute this out, right, I would have negative 12x squared and some other stuff. Okay, but I know that the highest power is going to be x to the 2, so that's all I really need to worry about. And then when I square this thing, I know it's not going to be 4x plus 49, or 4x squared plus 49. It's going to be 4x squared plus some other stuff plus 49. It'll actually be, I think, plus 28x. But we don't need to worry about that because all we care about is the ratio of the leading coefficients. So the horizontal asymptote for this thing is going to be y is equal to negative 12 divided by 4. And there's only going to be one of them because I don't have anything different happening when I go to infinity versus negative infinity. You take a positive number, you square it. Take a negative number, you square it. It's going to come back positive. And even if it came back negative, it'd be negative down here, right? So whatever it is, it's the same on both. So it's going to be one horizontal asymptote. Okay, so this one, we're interested in h equals 3 plus 2 to the x over 5 minus 7 to the x. Yeah. And the limit as x approaches infinity of h of x. Okay, I'm looking for the biggest thing I've got. That's at 7 to the x. That is bigger than 2 to the x. Okay, not like when I have 2e to the x and 7e to the x. They're essentially the same. 7 to the x is categorically, faster growing than 2 to the x. So I'm going to say this is bigger on bottom. This is going to 0. But as x approaches negative infinity, I know these exponential bits are going to go to 0. That's going to go to 0. That's going to go to 0. So this limit is going to become 3 plus 0 divided by 5 minus 0, 3/5. Okay. Move that up a little bit. Number 3, the graph of, y equals ax plus b divided by x plus c has a horizontal asymptote y equals 2. Well, this is same on top and bottom, so the ratio of the leading coefficients is 2, meaning a divided by 1 equals 2. So I'm going to say that a equals 2. Okay, and we have a vertical asymptote at x equals 3, meaning that when we plug in 3 right here for x, that means we have to be dividing by 0. That's what causes division by 0. So I'm going to conclude that c has to be negative 3, right? Because if c is negative 3 and x is 3, then we're dividing by 0. Okay, then a plus c is going to be 2 minus 3. A plus c equals negative 1. Okay. And, give a sketch of the function described. Okay, so approaching, we're interested in what happens as x approaches 1. So say that's 1. Appears that there's going to be a vertical asymptote. And the horizontal asymptote is y equals 2. And they say as x approaches 1 from the negative side, the limit is infinity. Okay, now a horizontal asymptote can definitely be crossed. Okay, so maybe I'll just draw it like that. But if you drew it just respecting that horizontal asymptote, there are functions that do that. Okay, but it can be crossed as well. What else was I going to say? Oh, and then as I approach from the positive side, that's negative infinity, and so maybe it's like that. Now that would be a good sketch of the function. Okay, number 5. Shown it right is the graph of, it's another one very similar. Ax squared plus 12 divided by x squared plus b. Okay, I'm not going to draw you a picture of the graph, but I can see that there's a horizontal asymptote at y equals 3. Okay, meaning, again, that the ratio of a over 1 needs to be 3, so I'm going to conclude a equals 3. And then we have a vertical asymptote at x equals 2, meaning that when I plug in 2 for x, I need to be dividing by 0. Okay, that means, I've got 4, b needs to be negative 4. Okay. All right, now on to set D. I'll just copy the problems real quick. All right, here's 3 limits at infinity. It's just like, we're going to compare different types of functions, Now we know that log of x is the slowest growing of all the functions that we look at. And so x to the 99 is certainly going to go faster than log of x, so we're bigger on bottom. This limit is 0. E to the x grows faster than log x, so we're bigger on top, that's going to go to either infinity or negative infinity. And you think, okay, I'm going to plug in a positive number here, positive. Log of a large positive number, remember that's the special exponent we put on e to get a huge positive number. We're considering what happens to log as x goes to infinity. And we're going to need to put a huge exponent on e to get a number back that's going to be huge. So that's going to be positive infinity because it's positive divided by positive. Okay. Then, okay, this one, heavier on bottom because exponential e to the x grows faster than any power of x. Even a large power of x like x to the 99, that's still not going to be fast enough to counter e to the x. And so that's bigger on bottom, and so that's going to go to 0. All right, this is a multiple choice question, and it says the vertical line x equals 2 is an asymptote to the graph of y equals f of x. So we know that, like maybe it's going like that or something. Okay. What we know is that f of 2 can't exist if that's an asymptote. And moreover, I don't think that the limit as x approaches 2 of f of x can be anything except for maybe infinity or negative infinity. Okay, so I'm thinking that answer choice A is impossible because there's no way we could have the 0. Okay, that would be like if there was a hole in the graph on the x-axis at x equals 2, right? And it was otherwise continuous, right? We aren't seeing that. It's an asymptote. We're going away from 0. So A must be false. All right, and last is going to be section F, and this is a good set of problems here. So the limit as x goes to infinity of negative log x divided by x to the 4, and then subtract 1. Okay. Well, this is a bigger on bottom fraction. Right? X to the 4 grows faster than log x, so the fraction's going to 0. So I'm headed towards something like 0 minus 1 is negative 1. Okay. Then this one, limit as x approaches negative infinity of the square root of 2x squared plus 3 divided by 4x minus 3. This is one of our double horizontal asymptote situations. You see that square root of x squared? Remember, I need to be careful here. Okay, I know that, okay, essentially the same square root of x squared and x, right? But what I'm going to do is I'm going to say, okay, I know it's root 2 divided by 4, but it might be negative because I'm going to negative infinity. As x goes to negative infinity, this positive square root of a squared number doubled and added 3, that has to be positive, right? But this number, you take a large negative number and you multiply it by 4, that's going to be negative, right? And then you subtract 3 more. It's going to be even more negative. Meaning that I think that I need negative root 2 over 4. Or root 2 over negative 4 if that makes you feel better, because that's where the negativity is coming from. Okay, and right, I think I'm going to copy a couple more so you don't watch me copy. All right, there's one of them. Okay, this one, as x approaches negative infinity, e to the 2x goes to 0, okay, right? Because we're taking e to a large negative power, it becomes 1 over e to a large power, it's close to 0. Okay, and then I'm getting closer to 0 minus 4, so that limit is going to be negative 4. Okay. The limit as x approaches infinity of 2x cosine x, that fails to exist. Nothing specific is happening with cosine as x goes to infinity. It's oscillating back and forth between negative 1 and 1, so you could say that doesn't exist due to oscillation. Okay, that's kind of one of the rare ones in this class where we actually have limit non-existing due to oscillation. All right, number 5. All right, you can just watch me copy. I've got a class about to come in. I'm hoping I can finish this before they get here. We'll see. Okay, cosine x divided by x. Okay, cosine x is oscillating, right? But it is bounded, and it's stuck between negative 1 and 1. Meanwhile, x is growing larger and larger, so we're dividing by more and more, meaning the fraction's going to 0, and so I'm getting closer and closer to 0 plus 4, which is 4. All right. I'm hopefully going to get all 3 of these in. Oh, yeah, we got this. Over x to the 4. How's it going? Good to see you. I'm frantically, recording solutions to these practice problems. Let's see. All right. This is a big, oh wait, it is not a bigger on bottom fraction. This is a bigger on top fraction. So this is going to negative infinity, right? Because negative of a large positive number, that's going to be a large negative number. And then I add 3 to it. We're already negative infinity. Plus 3 is not going to help anything. That's going to be negative infinity. Okay. this is x approaching negative infinity of just an old-fashioned polynomial. This is a good question. I ask these occasionally. Okay, but we know that a third polynomial, at its most interesting, looks like that. It goes up, down, up. So as x approaches negative infinity, provided that the leading coefficient is positive, we'll be going to negative infinity as well. Okay, and lastly, the limit as x approaches infinity of negative e to the negative 4x plus 3. I'm going to rewrite this negative e to the negative 4x is the same as 1 over e to the 4x, or negative 1 over that. And I can see a lot easier that as x goes to infinity, this fraction is going to go to 0, and I'm going to be taking something like 0 plus 3, which is 3. And that's all for this set of practice problems.